Get my Apollo 3.5 ton unit unboxed today. See all the snow, but we're having some nice warm weather, so it'll be a good opportunity to get out here and get started on this project. So far I've been very impressed with the crating. It was excellent. No damage at all to the unit inside. It looks excellent. Everything on it, fit finish is wonderful. I haven't found any issues. They have foam inside to dampen sound, maybe also for insulation a little bit, but you can see on the electrical cover it has foam all the way on the inside. Very nicely done. All of the screws they have, you can see some of the foam pulled out when I took out the screws, but they all have these little silicone washers on them, so that includes all of these little bolts or sheet metal screws. They all have those washers, probably to prevent vibration, but it also just gives everything a nice tight finish. The top, when I pulled the top cover off, the metal is a good thickness. The finish on it seems to be very high quality. And this foam along the top of the coils, and so that gives a nice seal to it. Looking inside the unit, we live up in the mountains, so we have a lot of rodents up here. The only thing I see that I might do is there is a couple of small holes in the bottom. I can't really get a picture of them, but a couple of small holes in the bottom, looks like for a drain line and maybe something else, and I may spray foam those before I permanently install the unit, just to keep mice from getting up inside of it. But everything from the fan side into the mechanical electronic side is very well sealed. I just see a very small gap in there. Again, may spray foam that just to keep critters out, but so far I've been very impressed with the unit just in the initial unboxing. Inside of the panel here is where all of the electronics were, the thermostat and all the wiring and everything for it. So got all that unboxed inside. So there's our 3.5 ton Apollo heat pump unit all installed now. Been running for close to a week. Been very happy with it. So we've got our hot and cold water lines coming out. It's about 60 degrees outside today, so it's not running right now. Put in a 30 amp disconnect, ran number 8 wire to it, some watertight conduit to the unit. And the top one there is the low voltage lines going back into the house for the controller, and built the concrete pad. Pretty simple job there to just get it built. Some little anchors to anchor it down, install the rubber feet. When it runs, it's much quieter than a typical air conditioner. You can hear the fan when it's at full power, but it's not loud, it's not annoying. And obviously in the wintertime when you're using it, your house is all closed up anyway, so you're not gonna be hearing it. But even the room right behind it here, you don't hear that running at all. And once it starts scaling down to 40-50% where it typically runs, then you really don't hear anything. You can barely hear it when you open the door to listen for it. So I've been very happy with it. We pulled out our electric boiler, and it had a 150 amp breaker in our panel. This is now a 30 amp breaker. Like I said, most of the time once it gets up to temperature, it's running at 50 to 60% capacity anyway. So we've seen our average electric use drop from almost, cold days, 170 to 180 kilowatts per day. We've seen that number come down to 50. So that's a huge energy savings, exactly what we were hoping for and expecting. And so far it's delivering and performing perfectly. So I know in my own research, I would look at a lot of videos and pictures and things of radiant floor heat setups, and they all looked incredibly complicated, and so I thought I would just make a video of our setup here to kind of show you that it can be very simple and straightforward. So we've seen the outside unit, and that comes in from pipes. Run over to the corner back there, and it comes up into an air separator and expansion tank, so that as the water heats up and pressure changes, you'll have somewhere to expand to. That comes over to a pressure valve, so we can monitor the pressure. And you can see we've charged it to about 25 psi, and it's staying right where it should. We do have a bypass valve, so that if the system can't circulate for some reason, then it has a way to just go through the bypass valve there and return back to the outdoor unit. That's actually in the wrong position because the circulators are past that point. And anyway, that's a different discussion. This drain pipe is off the old system, just have not taken it out of the way yet. We did go ahead and add 2 pumps this time. Our old system just had 1. We did put 2 because now the outdoor unit is 12 feet below us, well, 10 feet below us, and then it pumps down and has to down into the downstairs. This is up in the attic, and then pumping back up. So by adding a second pump, we increase the head height while still maintaining the same circulation flow that we had. So put valves on either side of it so that if you need to change them out in the future, when you need to change them out in the future, because something always breaks, you have an easy way to shut it off and not lose much liquid out of your system. And you have standoffs here to support the PEX. They are not clamped tight. They're just holding it so that it can't move, doesn't sag with the weight of those pumps in there. These are variable speed pumps. Grundfos, I don't remember the exact model, but they're 3-speed. I have them both set on medium. That's plenty of circulation through the system. And then it comes out again, just joins back in another T, and then runs down this pipe. These are 1-inch pipes, and down into our downstairs manifold, which I'll show a picture of. And as it circulates and comes back up from the manifold, there's a return line here. It goes straight back over. There's a valve there, again in case there's any maintenance that needs to be done to the pipes, and back to the outdoor unit. So that's really all there is to it. You can add pressure relief valves and that sort of thing. Because there's no automatic fill in this system, there's really no way for it to build pressure to the point of being dangerous. So didn't really see a need to add other fittings in there. Every fitting is a possible leak point. PEX is very good at not leaking. Never run into an issue with a leak in a PEX joint. However, your MNPT fittings that you have going in, I use a combination of Teflon tape and pipe dope on them. Teflon tape first and then pipe dope. That seems to seal really well. Did have a small leak on this valve over here, and I had to tighten that up a little bit. But you can tighten those even when you have PEX fittings on there, which is nice. They will spin, so you can do that without any worry. And then just make sure these compression fittings are tight, because I did have a leak there. And then the pumps are triggered by the outdoor unit. I have one lead that comes back up from the outdoor unit that controls, it's the black wire, it controls power, 120 volt power on off. But then it's just, like I said, that one conductor that comes back up here that ties in with the neutral and ground from the same circuit. But that neutral and ground does not run outside. There's no need for that because the outdoor unit does not have a neutral. It does have a ground, it does not have a neutral. So it's easier to just tie it into the junction box and run a single conductor down there. So that's how those start and stop when the outdoor unit calls for them to start and stop. So you can see it's very straightforward. Expansion tank, pressure gauge, and then on the downstairs manifold, that's where we have the temperature gauges for going into the floor and coming back out. And like I said, been very, very happy with the system. Keeps the house a nice constant temperature.